processor operate the embedded system, you can take the ARM processor in order to store data. Data it communicated is most of the time, if the processor is operated with the ARM state, so it always operate on the 32-bit data. So each location stores 8 bit of the data. So 8 bits of the data. Each location stores 8 bits of the data. 8 bits. These are all called as a locations. Location 1, location 2, location 3, location 4, location 5, and these are having the address. For example, this may be address is 00. This is the address of the second memory location, 01, 10, okay, 11, like that address locations are there. For example, you can take the 32-bit data. So this is 32-bit data, 33, okay, 44, or you can write 57, 68. So this is 32-bit data, because these are all represented in the form of hexadecimal. So each digit of the hexadecimal, if you are representing in the form of binary, so each digit, hexadecimal digit, takes 4 bits. So totally 8 bits are there at the 32-bit. So in the case of the little endian, what happens? So this is what you can call it as a lower byte. This is what you can call it as a higher byte. This is what you can call it as a higher byte of the 32 bits. Okay, these are the middle bytes. Okay, and here it is a lower part of the memory, because it is its address is 00. So it is a lower part of the memory, and this part you can call it as compared to this. So this is higher part of the memory. So this is higher part of the memory. So in order to store the 32-bit data, in the case of the ARM processor, hence totally 4 locations are required. So in the case of the little endian, how these 32-bit data stored in the memory, sometimes higher byte to lower byte is stored, and sometimes lower byte to higher byte is stored. So if you are storing the lower byte of the data in the lower part of the memory, and higher byte of the data is stored in the higher part of the memory, so this is because its address is it is a 3, so it is a 00. So that's what it is called as a lower part of the memory. So this is higher part of the memory. So in such a case, middle is stored in the middle. Middle is stored in the middle, and this is stored in this memory location. Okay, so this is how the data is stored. 32-bit data is stored in the memory, because 32 bits you cannot store in the one location, because each location holds only 8 bits of the data. So you want to store the 32-bit data in the memory. So each 32-bit is divided into the 4 parts, each having 8 bits. So this part is called as a lower byte, and this part is called as a higher byte. So this is a lower byte is stored in the lower part of the memory, and higher byte is stored in the higher part of the memory. Such a storing concept we called it as a little endian. Whereas in the case of the big endian, the black is it is a little endian. So the black arrows are the little endian. So I will write here little endian concept, because 32-bit data is used. So 32-bit data is stored in the 4 byte of the location, memory location. Sometimes starting with this, and sometimes started with the opposite direction. Little endian. Don't get confused. Most of the student writes reverse answer. Most of the time question will be there in the VTU question paper. So it is a little endian. Most of the student get confused. Okay, 30 to 40% student, even though it is a simple, 30 to 40% student do the mistakes. Whereas in the case of the big endian, this byte is, I will show with the red. This byte is stored, the higher byte is stored in the lower part of the memory. So exactly reverse. So the higher byte is stored in the lower part of the memory, and lower byte is stored in the higher part of the memory. So this is what we can call it as a big endian. And middle is as it is. So middle is, this is stored here. Sorry, this is stored. So in this part, because it is a, compared to this, it is a higher one. So it is stored here. It is stored here, and this is stored. So this is stored in this memory location. First 68, okay. First 33, then 44, okay. Then 57, then 68. So this is in the case of the big ending. Red are shown big ending, black is showing the little ending. Big ending. So big ending. Okay, so this is a storage concept used in the ARM processor, and the default storing concept is a, it is a little ending only. You want, you can change it to the big ending, so it is possible. Okay, while writing the program, in the beginning, before writing the program, you need to specify above the program. It is like a header file. So the concept used, storage concept used is a, you need to specify it as a big endian. Otherwise, default storage is a little endian. This is a lower byte is stored in the lower part of the memory, and higher byte is stored in the higher part of the memory. Okay, why this the little endian and the big endian? Because the ARM processor operate with the 32-bit data or instructions, whereas this is not so in the case of the 8085 processor, because it operates with the 8 bits of the data. Hence, one bit is stored in the this location, second bit is stored in the, second byte is stored in the this location. Only thing is that in the case of the embedded system, it operates with the 32-bit. That's what this little endian and the big endian concept comes into the picture. These are the storage